Okay, for today, we will still continue on the frame and machine, and in the additional class later, we will still continue about the frame and machine. And starting from Thursday next week, we will discuss new topics about distributed force. Okay. Just share the screen. Yeah, by the way, I already sent it to our my assistant to send it to you guys via EduNext about the 7th homework on the frame and machine. Okay, the deadline is next Thursday, Thursday next week, 10 a.m. before the class. Okay, and there are 5 problems that I give to you guys for you to be able to practice more on the frame and machine. And this is problem number 1. Number 2, so there are several mechanisms here where you can practice on solving the frame and machine problem. Okay, and some of the past exam problem, I give it as well there for you to be able to measure yourself if in your current state you have to go to the exam, what will happen. Okay, so you can see here, this is the past exam problem, one of the past exam problem. Number 3, 4, and 5, I took it from the past exam problem. Okay, so you can practice from this, and hopefully you can do that. If you have any problem in the next class, we will discuss about it. Okay. I'm not sure whether they have posted it yet or not, but I believe by today, my assistant will post it in the EduNext, so you can check for the file, for the PDF file of this homework problem. Okay. Now for today, I will still concentrate on the frame, exercise on the frame problem. Okay. But of course, the homework problem, I will not discuss it here, but there are some other problem that we can discuss. Okay. So some of it. Yep. I think for today, I want to discuss at least two problems. Okay. So this is the first problem that we will discuss today. Okay, let's start it. I want you guys to read about this problem. Okay, try to read about this problem and try to understand first about the problem given here. Okay, after that, we will discuss further about how to solve this. Okay, so already 29 of you who came already in the class. Good. So basically, while you are reading on the problem, this one, okay, I will re-explain about this. So actually, this one is a hand pressure hand pump, high pressure hand pump, okay, which is used to boost the oil pressure in the hydraulic line. Okay, in the current condition, okay, when theta is equal to 15 degrees, okay, and the given force is 120 Newton, okay, you are asked to find the oil pressure P, which acts on this piston, 46 millimeter diameter piston. Okay, so basically the one that is asked, the one that I asked for you guys is the delta pressure. Okay, so actually you don't have to care about the atmospheric pressure. Okay, do any of you have somewhat a solution for this? I'm not so sure whether you have seen this kind of device before, but in the past, the same system, okay, the same kind of system, we use it for pumping water, in the house like that. I'm not so sure whether you have seen it or not. Jadi di masa lalu ya, in the past, alat seperti ini, alat yang serupa itu digunakan untuk memompa air, ya, memompa air di rumah biasanya. Okay, have you guys ever seen this or not? Hello, Raffi, have you ever seen this kind of device?
Yes, sir. The one that pumps water.
Yeah. Where did you see?
I often seen it in kuburan gitu, sir.
Kuburan?
Yeah, there are lots
cemetery.
of them.
Oh.
Yeah, like cemetery.
So this kind of device is olden days device. So I'm not sure whether the others beside Raffi have seen it, but this device is there. Normally we use it to pump water, but it can be used as well to add pressure to the hydraulic line like this. Okay. Okay, Raffi, do you understand about the problem then?
Do we need to find the force exerted by C, the beam C?
So this one, right? Yeah. So the force divided by the area of the piston, the cross-sectional area of the pistons will become the pressure, of course. So basically, as long as you found out the force happening there, that's actually the answer. Okay, although you have to process more on it. Okay, and for this particular problem, okay, for this particular problem, can you guys identify the two force member here? As usual, whenever we want to solve a problem, we supposed to start with identifying the two force member. Okay, identifying the two force member first, and then the rest of the multi-force member we have to isolate it. Okay. Raffi, can you identify which one of it is a two force member?
Is it AB, sir?
AB, yes, correct. AB is two force member. Okay, how about C? The beam C, is it two force member or
not? From C to the piston, right, sir?
Yep. Yeah, C to the pistons. Is it two force member?
No.
Yep. Actually, it's not two force member. So basically, as you can see here, it's AB. It's there is a pin at A and B, and there is no friction there. Okay, but if we take a look at the C, the rod C until the piston, if we draw it, it's supposed to be more or less like this. Please excuse my drawing. This one is with the pistons, and the pin is here. And because the piston is in contact with the wall, piston with the cylinder wall, okay, there will be, of course, a moment here. Okay, there will be, of course, a moment there. So, so it won't be a two-force member. But don't worry, we still can solve it, even though it's not a two-force member. The one that we need the most is just the vertical force here, which is happening there. So the vertical force there is supposed to be action and reaction with the pressure, which is happening at the bottom of the piston. Okay. Now let's take a look at the. In order to solve this, which multi-force member that we have to solve, Rafi?
The beam on A, sir. A to
P, you mean?
Yeah.
Yep. Okay, correct. So we have to draw that. So, for example, this is the beam. We have what forces that we have there, Rafi?
Reaction forces on A.
Okay. What is the direction?
AX and AY, sir.
Are you sure X and Y? I told you you already determined that AB is two-force member.
Oh, just A, sir.
Yeah. So FAB, okay, in the direction of AB. FAB, like this, okay?
And then P at the end.
P at the end. What else?
And then the FCP, C piston.
CB?
C piston, FC piston.
C piston. Based on our discussion before, seems like you haven't waken up yet, right, Rafi? Based on our discussion before, C to the piston is not two-force member, right?
So, yeah.
Okay, if it's not two-force member, then we have to put
Reaction first.
CY and CX there. Okay. Okay, Rafi?
Okay, sir.
So this is basically our free body equipment. P there is 120 Newton. So guys, please remember, okay, the purpose of determining which of the member is two-force member is to simplify the problem. Once you determine that, for example, member AB is two-force member, then if we try to analyze this particular member, member AC, multi-force member AC, then at A, yeah, at A, it is you're supposed to put FAB instead of AX and AY. Why it's like that? Because we know already that this member is two-force member. When it's two-force member, the direction of the reaction force must be okay in the same line of action as the member. That's why we give it like this. Okay. And the other thing, we have decided as well that the member, the rod C to the piston, okay, this one, C to the piston, is not two-force member because there is a moment which is happening at the wall, the cylinder wall to the piston at the end. Okay, so it's not two-force member. Yeah, and because of that, because C to the piston is not two-force member, then instead of drawing C to the piston force, just straight line like that, we have to put CX and CY. Okay, so that's the purpose of determining which one is the two-force member and which one is non-two-force member. If it's two-force member, the reaction force is supposed to be just the reaction force is supposed to be just one line only, one force only like this. If it's not the force member, then you're supposed to put reaction force of a normal pin. Okay, Rafi, do you get it?
Yeah, I get it, sir.
Now, from this one, Rafi, can we solve this problem, Rafi? The angle here is 15 degrees. Can we solve the problem, Rafi?
Yes, sir.
Yep, because we have three equations, right? Sigma fx equal to 0, sigma fy equals 0, and sigma moment equals 0. And we have three unknowns, cx, cy, and fab. Okay. And in order to find out the oil pressure P, okay, which one that we will have to use, which one that we have to use later, which one that we have to divide by the cross-sectional area of the piston here? Which one, Rafi? From those three?
I'm guessing it's CY, sir.
Yes, correct, CY. So later, the pressure will be CY divided by the cross-sectional area. So pi multiplied by the diameter square of the floor. Like that. Okay, but remember, guys, okay, when you do this calculation, please be careful about the units, okay? Because here, the diameter units is in millimeters. Okay, so later, if you divide Newton, CY will be in Newton with a millimeter square. What you will get will be megapascal instead of pascal. Okay, but you will get is Newton per millimeter square. So it's supposed to be equal to megapascal. Okay. Any question here, guys? Apakah ada pertanyaan di sini? Jadi intinya adalah kita mencari CY di sini ya, mencari CY di sana dari diagram benda bebas pertama. Kemudian untuk mencari tekanan hidroliknya, itu nilai dari CY dibagi dengan luas dari cross sectional area dari si piston. Pi D pangkat 2 per 4. Oke. Kelihatannya cukup jelas ya. Fatimah Nadine, do you understand about this?
Yes, sir.
Okay, good. Shanwiria, how about you, Shan?
Yes, sir.
Okay, good. And then let's move to the next problem. Okay, this one. This one is quite quite similar to this problem, but slightly more complicated. Okay, for this problem, actually just by using one side only we can finish it. But this one is the same. By using one side only, we can finish it. But there are two free body diagram that we need to solve. Okay, as you can see here, so the mechanism is slightly more complicated. Yeah, the mechanism is slightly more complicated, and but it's still symmetrical. It's still symmetrical. What does it mean by symmetrical? It means that by solving one side only, you still can solve the problem. So it's like this. You can just finish the problem by solving this and this. Okay, those two free body diagrams, or this and this one. So it's up to you guys which one that you want to choose. Okay, the main question here is if we give a force P here, okay, what is Q, the punching force, in terms of P? So, Q in terms of P. Jadi, yang ditanyakan di sini itu adalah apa namanya, gaya pemukulannya di sini ya, dalam P. Apabila grip yang diberikan di sini itu adalah P besar. Oke, seperti yang tadi saya sudah bilang, ini symmetrical. Jadi asalkan kalian menyelesaikan salah satu sisi saja, tidak ada masalah, bisa ini dan ini. Oke, opsi selanjutnya adalah bisa menyelesaikan yang ini dan ini. Oke, jadi di sini kalian harus menyelesaikan dua diagram berbebas. Sedikit lebih complicated dari permasalahan serupa yang sudah pernah kita bahas. Ya. Raditya Wimanajati.
Yes, sir.
Oke, Raditya. Which free body diagram that we supposed to solve first? Raditya. There's only two options, right? Wait. I'm sorry. I changed the question. Can you see any two force member in this particular problem? We're supposed to start with that. Always, every time.
No.
There is no two force member. So the two free body diagram that I'm talking about is both are multi-force member. Okay, so now the next question, which one that we're supposed to solve first? Aditya. Okay, let me guide you. The known value is which one?
P.
P. Okay. So normally, the free body diagram that we have to solve first is the one with the known value, Aditya. Normally, it's like that. Yes, of course, some other special case, it's not necessarily always like that, but it's easier bet, okay? Better bet if you solve the free body diagram, which has the known value. So which one then, Raditya?
The handle.
The handle. Okay, we will try with the handle first. Do you want the top handle or the bottom handle? Hello, Raditya? Which one do you prefer? The top handle or the bottom handle?
The top.
Top handle. Okay. Let's draw the free body diagram of the top handle. Okay. What forces that we have there, Aditya?
P.
Okay, we have P. What else?
The reaction force on the pin.
Which pin? We have 3 pins, right?
Yes.
Which one?
The top one.
The top one. Okay. For the top one, as you can see there, it's like a slider, right? If it's a slider, what forces that you're supposed to put there?
Fy.
Only Fy, correct. So I will name it then. In order for us to not confuse about it, I name it as A, this one as B, this one as C. Okay. So this one will be AY. At B, how about at B?
Bx and by.
Bx and by, correct. Okay, how about at C?
CX and CY.
CY. Okay, can we solve this?
No.
Raditya? No. Then what we supposed to do then? What are we supposed to do in this case?
Try the other free body diagram.
Sorry, draw the other. Okay, let's try to draw the other free body diagram. Okay, what forces that we have there?
CX and CY.
X, CY. CY. Sorry. If CX and CY is going to the up and right there, in this particular free body diagram, we're supposed to draw it like what? Okay, Raditya?
Down and left.
Okay, correct. Down, CY, and left, CX. Okay. And what else that we have there?
The AY.
AY here is supposed to be
Down.
down. Okay. What else?
Q.
Q. Okay, because it's a punching, so it's supposed to be down as well, right? Okay, this one is Q. So how can we solve this then?
Using sigma moment.
Okay, sigma moment at which point? C, you mean? Hello?
Yes.
Okay. Sigma moment at C equal to 0. Then what we will get then in that case?
AY times 2A.
So later in this case, I will not solve it until the end. Okay. What we will get is AY in terms of Q. Okay.
Yes.
So then what we supposed to do after that?
Maybe sigma FY.
Sigma Fy. So wait a minute. Let me check first. The number of unknowns that we have here. Let us take a look. Okay. Because we have to check about the number of unknowns. P is known value. AY is unknown. PY is unknown. PX is unknown. CX is unknown. CY is unknown. So we have 5 unknowns there. And then beside that, okay, beside that, we have this way, Q as unknown. Correct or not?
Yes.
Okay. In total, how many unknowns that we have?
6.
6 unknowns. Okay. In total, we have 6 unknowns. And in total as well, from the first free body diagram and the second free body diagram, how many unknowns do we have?
Sorry, can you repeat the question?
From the first free body diagram, we have how many equations? And from the second free body diagram, we have how many equations?
3 from the first and 3 from the second.
Okay, 3 from the first, 3 from the second. Okay, there will be 3 equations: sigma fx 1 equal to 0, sigma fy 1 equal to 0, and sigma moment 1 equal to 0. Here is the same: sigma fx2 equal to 0, sigma fy 2 equal to 0, and sigma moment 2 equal to 0. So in total, how many equations that we have, Aditya? 6 equations. Okay, actually by using substitution and elimination, we will be able, to solve for this unknown. Okay, Aditya. So basically, what we supposed to do, is supposed to be simpler. Yeah, it's supposed to be simpler to solve for the second free body diagram. Okay, this is the things that I can suggest you guys, because in the second free body diagram, we only have 4 unknowns. Okay, and using like what Raditya did just now, okay, we can get AY in terms of Q by using sigma moment at C. And then using sigma fx equal to 0, we know that Cx is 0. Correct, Raditya?
Yes.
Okay, and by using sigma fy equal to 0, we will know Cy in terms of Q as well. Correct? Okay, Raditya?
Yes.
Yeah, by using sigma fy2 equal to 0, what we will get is Cy in terms of Q. Okay, then the equation Ay in terms of Q and Cy in terms of Q, okay, you can put it here in the first free body diagram. Okay, so later you don't have Cx anymore because Cx is 0. Okay, Cy it will be in terms of Q, so the variable there will be Q. Ay will be in terms of Q as well, so the variable there will be Q. Okay, so at the end, in the first free body diagram, we have 3 unknowns: Q, which is there in the Ay and Cy, but the variable is Q. Okay, Q, Px, Py, and we can solve it. Do you get it, Raditya?
Yes.
Oke, ini saya coba ulang kembali ya untuk menyelesaikan ini. Secara keseluruhan, ini yang perlu kita lakukan itu adalah menghitung jumlah unknowns, jumlah yang tidak diketahui, dan juga jumlah persamaan secara total. Nah, dari kedua diagram benda bebas yang sudah digambar, total ada 6 unknowns. Oke, total ada 6 unknowns. AY, PXPY, CXCY, dan Q. Total ada 6 unknowns. Nah, dari 2 diagram benda bebas juga, total ada 6 persamaan. 3 persamaan dari diagram benda bebas pertama, dan 3 persamaan dari diagram benda bebas kedua. Nah, kita punya 6 persamaan, 6 unknowns, kita bisa selesaikan. Caranya bagaimana sebenarnya terserah kalian. Nah, salah satu paling gampang, seperti yang tadi saya bilang, selesaikan diagram benda bebas kedua dulu. Oke, pakai sigma moment di C, kita dapatkan AY dalam Q. Pakai sigma Fx, kita dapatkan Cx sama dengan 0. Pakai sigma Fy sama dengan 0, kita bisa dapatkan Cy dalam Q. Nah, AY dan Cy dalam Q, kita gunakan di persamaan pertama. Jadi AY-nya kita ubah dalam variabel Q, Cy-nya kita ubah dalam variabel Q, Cx-nya 0. Nah, dari situ kita bisa tahu bahwa hanya ada 3 unknowns lagi di persamaan pertama. Q, yang merepresentasikan AY dan CY. Oke, CX-nya 0 ya. Berarti Q 1, BX, BY. Jadi tiga persamaan saya, tiga yang tidak diketahui saja dari diagram benda bebas pertama. Nah, dari situ kita bisa selesaikan nilai Q-nya itu berapa dalam P. Seperti itu. Gitu ya. Apakah ada pertanyaan terkait dengan soal ini?
Sir, I'd like to ask,
Yep. Who's this?
Raffi,
Oke, Raffi. Yes.
since we'd start by finding the moment on C,
Hmm?
what would be the distance for Q to C, sir? Is it 2A?
Yeah, there is no dimension there. Actually, it's supposed to be 2A. There's supposed to be a dimension there. Okay. Yep.
Okay, thank you, sir.
Mhm. Okay, I think I will continue. This one will be your homework problem, so I will not discuss it today. Okay, this one, I think I will not discuss it as well. This one will be part of your homework as well, so I will not be discussing it. This one we discussed it yesterday. This one we discussed it yesterday as well. Just now we have finished this. There are actually several interesting cases. Okay, then. I think I will try to ask you to solve for this particular problem. Okay, we can try to solve for this particular problem. Okay, I'm sorry, the problem is in Bahasa Indonesia because I don't know why the same problem is not there anymore in our Merriam book, but in the old Merriam book, yes, it is there. And unfortunately, it's only available in Bahasa. Okay, but I believe you can understand what. So it's kind of scissors, but the bottom part and the top part of the scissors is unsymmetrical. Okay, unsymmetrical. And it is normally the scissors normally used to cut the can. Okay, and it is known that the force given at the handle is high 50 Newton. And you are asked to find out the cutting force P, okay, at this particular point. Yeah, the cutting force there. Okay, actually it's not that hard, but it's slightly more complicated than the one before. Okay, but I want to check with you guys. Can you find out the two force member in this particular problem? Davi Rizky. Halo, Davi. Hello, Davi.
Hello.
Yep. Davi, can you find out the two force member here in the scissors? Is there any two force member in the scissors?
Maybe the middle section.
You mean this one?
Yes, sir.
Yep, correct. That one is two force member. So remember, okay, that one is two force member. So we do not need to draw the free body diagram of that one. And we know the line of action of the force at the pin here And here, due to that particular member, we know already the direction. Okay. Based on your analysis, which one that we supposed to solve? The bottom part or the top part? Is it this one? Or the other one? This one? Hello? David?
The top lah.
The top one. Okay, let's check with the top one. Okay, if we draw the top one, okay, it's like that. Please excuse my drawing. Okay. What forces that we have there, David? The top one.
150.
150 here. What else? What else, David? There is a pin here,
The
and there is a pin here. Okay, at the pin, what will be happening at the pin?
X and FY.
Okay, I will name it then. This one is A, this one is B. Okay, till there will be AY, AX, BY, BX. And beside that, we have a cutting force as well, right?
Yes.
Okay, Q here. And from this, how many unknowns that we have?
4.
4. Are you sure? 4. BX, BY, AX, AY, Q.
And
So in total, there will be 5, right?
yeah.
Okay, 5 unknowns, and we only have 3 equations. Can we solve this?
Not sure.
Nope, we cannot. So actually, it is better for us to. Actually, it's okay for you guys to try it like this, but later, after you get better understanding on this, you can sense from the beginning, based on your initial analysis, that one thing is possible or not like that. But in your state, you can try like this. Okay, this one is not possible. Okay, solving the top part is not possible. Then, if it's not possible, try the other way, bottom part. Okay, in the bottom part, how many free body diagram that we have to draw, David? So this one is not possible. Okay, I will just delete it. Now, for the bottom part, how many free body diagram that we have to draw?
3.
3, which?
The handle.
Yeah, this one is, you don't have to draw, right?
Oh,
That one is 2 force member.
2.
So only 2. Yes, only 2. Okay, remember, you don't have to draw the free body diagram of the 2 force member. Okay, so only 2. Okay, the first one is the handle. Okay, let's draw the handle. Okay, what forces that we have there?
150.
150, yes. What else?
AX, A1.
XAY. What else? I name this CD, okay?
And FCD.
FCD, correct. FCD. Okay, I will just keep it like this. Wait a minute. If it's under tension, it's supposed to be going towards 3. I give it under tension. FCD. Can we solve this free body diagram?
Yes.
We can solve it because we have three unknowns, AX, AY, FCD, and we have this one is our first free body diagram, and we have two equation, sigma fx equal to 0, fx1 equal to 0, sigma fy1 equal to 0, and sigma moment 1 equal to 0. So we can solve FCD, AX, and AY. Okay, after we solve those three, we can go for the next free body diagram. Okay, the next free body diagram is supposed to be the cutting part, right, Davi?
Yes.
So we will draw the cutting part. Okay, what forces that we have there? There's supposed to be D over here and B over here. What forces that we have?
FCD.
FCD. FCD is supposed to be going down or up?
Here down.
Are you sure? Here we,
Up.
yeah, it's supposed to be action and reaction. Okay, actually it's based on your results of the first free body diagram. Okay, if the result is positive, which means that this direction is correct, then FCD is supposed to be going up because it's supposed to be action and reaction. But if the result is negative, then we know that the actual direction is supposed to be going up positive. The positive direction is supposed to be going up. Then this one is supposed to be, the other one is supposed to be going down. Do you get it, Davi?
Yes, sir.
Okay, so this one is FCD. What else?
BX, BY.
BXPY. What else?
And the load.
The load, the Q, okay, is supposed to be going up. Okay, FCD, we know it from the previous free body diagram. So we are left with Px, Py, and Q as the unknowns. And we have three equations. Sigma Fx2 equal to 0, sigma Fy2 equal to 0, and sigma moment 2 equal to 0. Okay, correct, right, Davi?
Yes, sir.
Can we solve this?
Yes, we can.
Yeah, we can. We can solve for Px, Py, and Q. And Q is the main one that we have to solve. Px, Py is not us. That's why actually we don't have to solve using these two equations. We can just use sigma moment at point B in order to solve for this one. Okay, is it understood, David?
Yes, sir.
Simple, right? So basically that's all the topics of that's all the things about the frame and machine. I suggest to you guys to practice more and more, because by practicing more and more, you will get more sense of engineering to analyze it. So you will be able, I'm sorry, I'm laughing a bit because just now my wife was mocking me. Okay, you will get a better sense of engineering to analyze the thing, to solve the things. Okay, you will know about the steps to solve the things. Okay, you will know how to judge faster which one is two force member and which one is multi-force member. Okay, and you will know as well which direction that we're supposed to take like that. Okay. I think that's all for today. Okay, thank you very much for coming. But before I before I close the class, okay, before I wrap up the class, I think wait a minute. Stop recording.